So I'm going to start off by reviewing factoring and solving. To begin with, we're going to always try to common factor first. So if there are two terms, we're going to look for the difference of squares. If there are three terms, we're going to look at the perfect square trinomial, then the simple trinomial, and then the complex trinomial. And if there are four terms, we're going to look at factoring by grouping. So I'm going to go through some examples with you. The first one over here, we can see that we can easily common factor it first. So I'm going to factor out the 3ab, and then the brackets 1 subtract 9b plus 3a, and that's your answer. The second one over here, the difference of squares. So we're going to set up our brackets. Square root the first term, 9, so plus and minus. Square root the first term, so 3x, and square root the second term, 5y, so 3x and 5y. That's your answer. The third one over here looks like a simple trinomial. We're going to find two numbers that multiply to give us negative 21, two numbers that add to give us 4, and then we're going to plug it in. A plus 7 times a subtract 3. That's your answer. The fourth one over here is a perfect square trinomial because of the 9 squared and then 3, and then the 6. So what we're going to do is 9x squared plus 3x plus 3x plus 1. So basically I got the 3x from two numbers that multiply to give me 1 times 9, two numbers that add to give me 6, which is 3 and 3. And then you do 3x, you're going to factor out the 3x, 3x plus 1, 3x plus 1, and this gives us 3x plus 1 squared. And that's your answer. For quadratic equations, solve means to find the x-intercepts. To find the number of roots, we can use the quadratic formula or the discriminants. The quadratic formula, so the b squared subtract 4ac, or the discriminant formula, b squared subtract 4ac, both give us the number of roots. So if the value is more than 0, there are going to be 2 roots. If the value is less than 0, that means there are going to be no real roots. And if the value is 0, there's going to be one real root, which is going to be most likely the vertex. So now I'm going to go on to solving the two equations, quadratic equations. So we're going to start off by finding two numbers that multiply to give us negative 5 and 2. Now also remember that when we solve equations, we must make them equal 0 because we're finding the x-intercepts, and the x-intercepts occur when y equals 0. Hence we're going to substitute in 0 for the y value, and we have to bring the 5 over here onto this side of the equation. So it's going to be 2x squared minus 3x minus 5 equals 0. Equals 0. So now we have our we can put this into two brackets over here. So 2x minus 5 and x plus 1 equals 0. Now make each bracket equal to 0. So 2x minus 5 equals 0. X plus 1 equals 0. And we're just going to solve for the x value. So 2x equals 5 divided by 2 divided by 2. X equals 5 over 2. So the first root, we can say the value is 5 over 2. The second root, x equals negative 1, so bring the 1 to the other side, and that's the second root. And that's your answer. So for the second question now, we're going to start off by multiplying, so two numbers that equal negative 6 over 2 over 3, which basically equals negative 4, for two numbers that multiply to give us negative 3. Negative 4 and 1, negative 4 and 1. So we're going to start off, because this equation is already set to 0, we're just going to start off by plugging these in. So 2 over 3x squared minus 4x plus 1x minus 6 equals 0. We're going to isolate, so we're going to take out we're going to factor out the 2 over 3x. 2 over 3x times 6x minus 6 plus 1x plus x minus 6 equals 0. 2 over 3x plus 1 times x minus 6 equals 0. And once again, we're going to solve for the x values. So 2 over 3x plus 1 equals 0. X minus 6 equals 0. Then we're going to have 2 over 3x equals negative 1. We're going to multiply it by 3. So this cancels out. 2x equals negative 3 divided by 2 divided by 2. And x equals negative 3 over 2. Over here on this side, we just bring 6 to the other side. So x equals 6. So the first root is going to be negative 3 over 2, and the second root is 6. So we're going to continue on by reviewing the functions part of the unit. Functions is the relationship between x and y, where there's a unique value of y for every value of x. We can determine a function by doing the vertical line test, or checking to ensure that all the y values are different for all or every x value. There were two types of functions taught in this unit, which were the quadratic functions and the root functions. So fx is basically saying f at x or f of x, and it means that what the question is basically asking is you're going to determine the y value when f is at like a certain x value. If we multiply these two numbers, this would be if we multiply these two, it would be wrong, because fx is treated as like any other variable such as y or x. It's just the function like of x. So we're going to continue on with the example. So determine f3. So when f is at 3, what's the value of y going to be? So fx equals 3, I'm going to sub the 3 in, squared, plus 2 times 3 minus 1. Fx equals 9 plus 6 minus 1. Fx equals 15 minus 1. Fx equals 14. And therefore, when x equals 3, y equals 14. Now we're going to continue on with the second one. Fx equals, so it's 5 over here, f at 5. Fx equals 5 square root 15 times 5 plus 5 plus 2. Now notice how the 2 is outside of the square root brackets, hence it will not be square rooted with these numbers. Fx equals 5 square root 50 plus 2. Fx equals 37.36. And that would be your answer. So therefore, when x equals 5, y equals 37.36. Now we're going to continue on by checking, going through these examples of and determining whether or not these are functions or not. So the first one over here, we have a circle, and this is not a function because at a given x value, there are two possible y values. So over here, if we look at, say, negative 1, there are two possible y values for negative 1 over here, which is why this is not a function. Number 2, this is a straight line going diagonal, so it's basically a straight line, and this is a function because there are different y values for every x value. So over here, if x equals 2, y equals 2. If x equals 4, y equals 4. The two numbers are not the same, and this is throughout the entire line. At number 3, it's a sideways parabola, and this is not a function because Once again, at a given x value, there are two possible y values. So say if we took -2, there are two possible y values for the x value of -2. We have a diamond over here, and this is once again not a function because at a given x value, there are two possible y values. Over here, if we take 1 as the x value, there are two possible y values. We have 1 as the y value and -1 as another y value, and hence it's not a function. Number 5 is a parabola, and this is a function because there is a different y value for every x value. If we look at, say, at the x value of -2, the y value would be -2. If we look at the x value of being +2, the y value would be 0 in this case. Hence, this is a function. So I'm going to continue on by reviewing the domain and range. Domains state all the possible x values, and ranges state all the possible y values. When given coordinates, we're going to list the domain within like curly brackets. So we list them using commas, so just list all the x values of the coordinates, and for the range you're going to do the same thing. You're going to list all the y coordinates in the same way. When given a function or a graph, so when you're gonna be given a function, you're gonna graph it to check like what the range and domain are. But when you're given a graph, then you just look, then you're gonna put this in, so x belongs to all real numbers such that, and you look for the limitation. So what's the maximum or minimum value of x, or what's the maximum or minimum value of y. So for parabolas, you usually look at the vertex, and for root functions, you look at the starting points. So over here, I'm going to go in more detail about what this means. So this basically says that x belongs to all real numbers such that, so x is an example of real numbers, so it's going to be like the decimals, and the same thing with the y belongs to all real numbers such that. So I'm going to continue on by doing the domain and range for the following. We're given a bunch of coordinates here, and we're just going to look at the x values to list the domain. So the x values 0, 1, 2, 3, and we're going to put d equals 0, 1, 2, 3, and for the range we have 5, 6, 7, and 8, 5, 6, 7, and 8. And when we're given these, make sure we list all of these values according, so from smallest to largest. And if any of the values by chance repeat, then you don't have to repeat them in the curly brackets, you just have to write it once. Now we're going to continue on by we're going to evaluate these graphs over here. So the first one over here, this graph, this is a function and it continues in both directions. So now we're going to look for the limitations of x. X does not have any limitations because this graph repeats and like continues on forever in both directions. Hence, we're going to write domain equals x belongs to all real numbers, and there is no like limitation. So we're just going to leave it at that. For the range, we're going to look at the maximum point because this parabola opens down, like it's not a parabola, but it opens downwards, and so the highest value of y would be 0 in this case. So y belongs to all real numbers such that y is less than or equal to 0. So this symbol over here, the less than sign or equal to sign, we're going to use that. And since all the values of y are going to be less than 0, so they're all going to be negative numbers, we're going to write that in over here. So that's the limitation of the y. Now looking at this graph, we have a straight line, and this does not continue in both directions because it's like a line segment. And in this case, the domain will be x belongs to all real numbers. But since we have limitations, x is going to be more than -2 and less than 3. So over here, this number. So x belongs to all real numbers such that x is going to be less than 3 and more than or equal to -2. And the range would be just 3 because it's on this, so the y value is always going to be 3 because it's a straight line and it does not change. So it's going to be 3. And that's about it.